All right, let's look at some U-substitution integration problems with trig functions. And these problems are from a sheet I handed my students. If you are a random internet person watching this, if you want the sheet with the problems, go to bit.ly/int-temp, int temp, which is short for integration templates, but whatever. So number 21 on that sheet is the antiderivative of sine of 7x, and I'm going to choose the 7x to be my u. That is on the inside of the sine function. So u is going to be 7x. U prime, which is important, you must find the u prime, is just 7. And so I'm going to squeeze a 7 in here because there wasn't already one. But if I put a 7 in there, I have to offset that with a 1/7. And now I see my u prime in the problem. So I have 1/7. There's my u prime sine of u. And so when you substitute everything out, it becomes the antiderivative. The u prime, along with the dx, merges into the du. Then we have sine of 7x, which I would rewrite as sine of u. Just don't forget that 1/7 in front needs to come along for the ride. Then when you do the antiderivative of sine, antiderivative of sine is negative cosine of u. There is still a 1/7 in front of that. And then we'll substitute the 7x back in the place of the u. And so my final answer is 1/7 cosine of 7x. And as always, don't forget your plus c. So there's the answer to number 21 on that sheet. So moving on to some other random problems. Let's look at 22, cosine over sine squared of x. This one's a little less obvious because you don't really have the parentheses, which sometimes people look for, like we have on 21, to indicate your u. However, sine squared is the same thing as having all of sine x squared, like that. And with those parentheses, now I see something that could be a u, and I do like sine. And the reason I like that for my u is because the derivative of sine is cosine, which is right here on top. And so you want to identify a function and its derivative. And so what I'm left with is when you substitute that out, you have the antiderivative of cosine x is my u prime, that's my du, so I like to stick that off to the side, du. There's nothing left in the numerator, so I'll put a 1 there to hold its place. On bottom we have sine squared, which would be u squared, and then we have to do the antiderivative of 1 over u squared. So the u sub, the objective is to clean up the function, make it a little less ugly, and cosine over sine squared is definitely uglier than 1 over u squared. 1 over u squared we integrate by bringing that u up, and we can do a nice power rule. Add 1, u to the negative 1 over negative 1, which is the same thing as negative 1 over u, and then we will plug our u back in. So my answer is going to be negative 1 over sine x plus c. And then, of course, if it's a multiple choice question or something like that, you also need to recognize that that is the same thing as negative cosecant x plus c. And I don't really care which of those two you give as the answer if it is free response. So there's 22. Let's see. 24. Now this is a sneaky one because if you were gonna try u sub, if you wanted to try u sub off the bat, you're probably looking, there's only one semi-ugly thing inside parentheses, and you're looking at that 2x. So you're probably thinking, hey, let's let that be u. Well, if 2x is my u, u prime is going to be 2 dx. And I could squeeze a 2 in here and offset with the 1/2. There's my u prime. The problem is that when you try to substitute that, you'll have 1/2 antiderivative. The 2 and the dx becomes the du. And I'm left with sine of u on the top, but we run into a problem in the denominator because I still have an x that has not been accounted for. When you're doing substitution, once you start taking one variable out, I started taking the x's out and replacing them with u's. You have to get every single x out of the problem, and I haven't been able to do that because x is not a u, it's not my du, it's just there. And in this case, u sub, at least using u equals 2x, fails. So we're going to abandon that Sorry for those of you who are writing in ink. And this one, there's a trick to this one. There are a few trig identities that come into play and can help you out with integration. And one of them is that sine of 2x is the same thing as 2 sine x cosine x. So if you make that change using just good old-fashioned algebra 2 and trig, Pythagorean, not Pythagorean, trig identities. So 2 sine cosine, I replace my sine 2x with that, put that over sine x, and what happens here? The sines cancel, and we're left with only the antiderivative of 2 cosine x, and cosine is the derivative of sine. So the answer is 2 sine x plus c, and it turns out no u sub was needed at all. Just had to use a little bit of a trig identity to make this function reduce into something more manageable. So 26, so let's try this one. This is very similar to, I think it was 24, 22. We had cosine over sine squared. Here we have sine squared over cosine. So almost the same, just flipped. And if I were to attempt this one, we could try the same thing we did earlier. I'll give you a warning, this is not going to work. I'm just going to show you what happens if you try the wrong approach. So if you want to hold off before you take notes on this. And so I'm looking at this, sine squared is the quantity of sine all squared. You might be thinking that this is a good choice for u. And if that's my u, if u is sine x, then u prime is cosine x. And so is there a cosine x in the problem? And you may be thinking that there is. There is a cosine in the denominator. However, that is not the same as cosine that I have here, because really this function, it's not sine squared times cosine. If you could rewrite it as sine squared of x times, and it's 1 over cosine. It's 1 over cosine, which is not the same as just cosine. So we really need my u times the u prime. We have u divided by u prime. So it looks like u sub would work, but it turns out that it will not. And this problem, we will start by again going to a trig identity. We'll go to a trig identity, and sine squared is the same thing as 1 minus cosine squared. And I'm going to use that identity here. So sine squared becomes 1 minus cosine squared of x over cosine of x. And then what we have here, I have 1 minus cosine squared over cosine. You can split that fraction. This is an STD. 1 over cosine, single term denominator. So we have 1 over cosine minus cosine squared over cosine which can be rewritten as secant minus cosine. And we now have two things to integrate. We have the antiderivative of secant and the antiderivative of cosine. Cosine is the derivative of sine. So when I integrate this part, the minus cosine x, that integrates to the antiderivative of that is going to be minus sine x. The antiderivative of secant, if you're one of my students, we have not talked about this in detail yet, to my knowledge. And this is one that's really best off just memorizing. I will show you the proof of this. You can prove this with U-substitution, but for now, I'm just going to tell you that the antiderivative of secant is the natural log of secant plus tangent. And honestly, it's better just to add that to your memorization bank. Don't forget to put a plus c on the end, and there is your answer. All right, and I believe that's the last one. Nope, I've got one more. So 27. I think it's one more. Yeah. So 27. We'll try U sub here, and this one's not going to be too bad. It looks horrific. It looks horrific. You have an inverse trig, you have radicals, but if you let this be your U, if you let the arc sine of x be U, the derivative of arc sine x, you all know, or should know, is 1 over the root of 1 minus x squared. And that's exactly what we have right here. This is 1 over the root of 1 minus x squared. So there is my u prime. So there's my u prime. So if you went through the formal substitution, you actually wrote this down. 1 over root 1 minus x squared is going to be your du. So I'll stick that off to the side. And then I have the cosine of arc sine, but cosine of arc sine x would be cosine of u. And cosine is the derivative of sine. So when I integrate cosine u du, it becomes sine of u. But I'm going to go ahead and cut out a step. We know that u is the arc sine of x, and this is an interesting one, plus c. And the sine of the arc sine of x actually cleans up to just x plus c. So that's a very interesting problem, and if I wanted to spend the time, I would investigate why it cleans up to being just x. It would require a lot of right triangles and other garbly poo, but there is your answer for 27.